Hello, this video is going to look at emulsions and emulsifiers based on the higher chemistry course. So the outcomes we're going to look at today are what emulsifiers are, what emulsions are, and the structures of emulsifiers and how they're formed. An emulsion contains small droplets of one liquid mixed with another liquid. Emulsions in food are mixtures of oil and water. So in diagram A, this diagram represents a layer of non-polar oil on top of polar water. If I was to shake this quite vigorously and agitate it, initially the water layer and oil layers will have formed an emulsion. However, if I leave it for a while, the unstable emulsion progressively separates back into the layer of oil at the top and water at the bottom. To prevent oil and water components separating into layers, we can add an emulsifier, which is a soap-like molecule, to the mixture to make the stable emulsion containing small droplets of oil and water. And the next video will demonstrate some examples of emulsifiers that can do this. Okay, I've got a jam jar here containing some olive oil and water. Notice that the two liquids do not mix because we have non-polar oil on top of water, which is a polar liquid. So we say these liquids are immiscible. I can try and get them to mix by agitating them like this, and you can see that I've got what's called an unstable emulsion. However, if I leave it for a few seconds, you can see that the oil goes back to the top, the water is at the bottom, and we get the two layers back again. To the oil and water this time, I'm going to put in some detergent. And give it quite a vigorous shake. And you can see now we have a stable emulsion being formed. The oil and the water do not return back to the layers that were in before. The way the detergent works is that the detergent molecule has a long hydrocarbon tail, which is soluble in oil. It will be soluble in the oil droplets formed from the agitation. The molecule also has a charged water-soluble hydrophilic head, which causes repulsion of the droplets of oil, therefore keeping them in suspension. If I want to make a stable emulsion we can eat, such as vinegar and oil that would be in a salad dressing, or oil and vinegar for mayonnaise, obviously I'll not want to add something like detergent to this. So what I can do is add an emulsifier such as mustard. So if I take this mixture of oil and water and I stick in some smooth mustard here, I'll probably need to give this quite a vigorous shake. And you can see that I have a stable emulsion formed here. So an example of this stable emulsion would be honey and mustard dressing, which is used as a salad dressing. And the mustard acts as an emulsifier to emulsify the oil and vinegar to create a stable emulsion such as this. Another example of an emulsifier is egg yolk. So if I have some oil and vinegar and I want to make a Caesar salad dressing, which is a bit creamier, I could add some egg yolk. It doesn't work with egg white, it needs to be egg white, I should say. It needs to be egg yolk, so I'm just going to put some egg yolk into here. It's quite thick. And give this a shake. This also works for mayonnaise as well. Mayonnaise is a mixture of vinegar, egg yolks and olive oil, which creates a creamy emulsion. So you can see we've got a stable emulsion here formed by the addition of egg yolk as well. So as you saw, an emulsifier can be used to prevent non-polar liquids such as oil and polar liquids such as water separating into two layers. And the examples I showed you earlier were detergent, egg yolk and mustard powder. And those emulsifiers can form a stabilized emulsion. Emulsifiers are soap-like molecules. Both soaps and emulsifiers are composed of a hydrophilic head and a hydrophobic tail. The hydrophobic tail will dissolve in oil, and the hydrophilic head will be soluble in water. And like soap molecules, when the emulsion is formed and you have droplets of oil, there'll be electrical repulsion between the droplets to help form the stabilized emulsion. Emulsifiers for use in food are commonly made by reacting edible oils such as glycerol to form molecules in which either one or two fatty acid groups are linked to a glycerol backbone, rather than the three normally found in edible oils. So if we take this glycerol molecule and we attach three fatty acids to it, we would get three ester links forming a fat or an oil. However, in the case of an emulsifier, we only join one or two fatty acid groups to the glycerol. So in this case, this emulsifier has had one fatty acid joined to the glycerol, creating an ester link and this hydrophobic part, which would be soluble in oil. These two hydroxyl groups on the emulsifier are soluble in water. These in turn will be hydrophilic. The figure below shows the structure of an emulsifier in which we've added one fatty acid molecule to the glycerol. So this is the bulk of the fatty acid molecule that's been attached. Note that it's mainly hydrocarbon, and this non-polar fatty acid chain is hydrophobic and soluble in oil. At the left-hand side here, we've got hydroxyl groups. The polar nature of these hydroxyl groups means that this part of the molecule is hydrophilic and soluble in water. This figure shows the structure of an emulsifier in which we've added two fatty acid molecules to the glycerol. So these are the two fatty acid molecules that have been attached, shown here. Remember, these are non-polar fatty acid chains which are hydrophobic and soluble in oil. And at the left-hand side, we have the hydrophilic head, which has a hydroxyl group, which allows this part of the molecule to be soluble in water. This animation on emulsifiers starts off with two bottles of water into which a few drops of oil are added. The bottle on the right is shaken to form an unstable emulsion. This unstable emulsion will result in two layers with the oil at the top and the water at the bottom after a while. If we add an emulsifier to a mixture of oil and water and shake it, we have a stable emulsion in which the droplets of oil are suspended in the water. An emulsifier can be formed by reacting one or two fatty acid molecules with one molecule of glycerol in a condensation reaction. This will form one ester link plus a molecule of water. Another fatty acid can be attached to form another ester link plus a molecule of water. Note that our emulsifier molecule has a fatty acid hydrocarbon chain which is non-polar, therefore oil soluble and hydrophobic. There will also be two hydroxyl groups which are polar, which will be soluble in water and in turn be hydrophilic. If we have a mixture of oil and water to which an emulsifier is added, the hydrophobic oil-soluble tail of the emulsifier will dissolve in the oil and the hydrophilic head will remain in the water, and there will be repulsion between the hydrophilic heads of the emulsifier, causing the droplets to separate into a suspension. Emulsifiers are frequently used as food additives, and they're used for various reasons. They can make food appealing, they help maintain quality and freshness, and if you have low-fat spreads, emulsifiers can prevent the growth of molds, which would happen if the oil and fat separated. Spaghetti carbonara has a mixture of fatty cheese and pasta water, and egg yolks can be used to emulsify this to create a creamy sauce. Salad dressings have a mixture of non-polar oil and polar vinegar, and in this case, honey mustard dressing, the mustard flour can be used as an emulsifier to create this smooth emulsion that can cover your lettuce leaves and so on in a salad. Caesar salads will have egg yolk as the emulsifier to create that creamy white salad dressing. Mayonnaise is another food that contains oil and water, so the emulsifier, often egg yolks, keep these mixed, as without it the oil and water would separate. Have a go at this question, pause the video and see if you get it right. So which one of these statements is true? Well, emulsifiers are formed by reacting fatty acids, which we get from the edible oils, with glycerol. We only attach one or two to the glycerol to create that emulsifier molecule. So our correct answer for this is B. So have a look at this question, pause the video and see if you can get the 2 marks. Okay, so looking at this molecule, you can see that we've got 3 hydroxyl groups. Whenever I see hydroxyl groups in a molecule, I think that this will make it soluble in water. So this is our water soluble or hydrophilic part of the emulsifier. You can see we've got a long hydrocarbon chain here, and this will be our hydrophobic or oil soluble part of the molecule. So to recap, you will get 1 mark for mentioning hydroxyl groups being hydrophilic or soluble in water or polar liquids, and another mark for mentioning the hydrocarbon chain being hydrophobic, insoluble in water, or soluble in non-polar liquids such as oil. Here is a final summary of the content covered in the video. I have to say, as I finished narrating this video, I've almost got a little tear in my eye. It's all been a bit, emotional. Sorry.